All right. Good morning, good afternoon, everyone. Joining this webinar that we have that we want to talk about McTrans CodeGREEN product. This is the new product that we are distributing at the moment. So today uh, uh, I have Fabio Sasahara, who is my colleague, who's the traffic engineer lead at McTrans, helping me, as well as James Blay with Rhythm Engineering, that's going to basically help me to go through this webinar. So before we go further, let me first do a quick walk through our agenda. So what we're going to do today is that I'm going to spend a few minutes talking about what is McTrans CodeGREEN, just so that you guys have a flavor of, what this product is about, what are the capabilities of it, what it can do for you, what type of problems it can solve for you. And then I'm going to be giving the floor over to James so that he's going to do a live demo of this tool, going over examples, basically showing all the capabilities, features. And then at the end, basically, we are going to go back to my presentation and see first what you all think about this product. And is there anything that comes to your mind that you wish to see in the next immediate release, in the short period of time, if we can do it for you. And then really at the end, open it for Q&A. So with that said, a quick note that we are recording this webinar and we are going to post this in our YouTube channel. Later, we are going to share the link with the community. So if you guys want to refer back to this webinar, or have basically shared with your colleagues or others that that this product might be of interest of them, you can do that later on. So let me first borrow a minute and say what is McTrans, what we do. So McTrans is it's a university center with the University of Florida. We have been in business for now close to 4 decades. And our specialty is developing and disseminating traffic and transportation and traffic related software. A few software that we right before this moment, we were selling and we are pretty famous for is one is highway capacity software, HCS, which basically replicates what is in the highway capacity manual. The other one is HSS, Highway Safety Software, that does the same thing as HCS does for HCM, but this does for HSM, Highway Safety Manual. Basically, parts of Highway Safety Manual, crash prediction methods, you can access them. It's like a calculator for you through HSS. Thesis Coursem is our macro simulation package that lets you model corridors, any surface street basically, and do macro simulation analysis. And now we are offering CodeGREEN as our next software that is basically what it does is that it helps you with signal timing optimization. We're going to talk a lot about it today. All right, so a glimpse into what is CodeGREEN. Basically, this is based on the work that is a collaboration between McTrans Center and Rhythm Engineering. It's a cloud-based operational level signal optimization software that has a lot of intuitive dashboards, powerful visualizations. It has a lot of analytics that's going to help users, to basically draw their conclusions and go about doing signal times. A couple examples would be it enables you to have a good visualization understanding of, cycle lengths. For example, how they change, what's the optimal cycle length changes through the day, and then you can come up, with proper judgment of, when you cut basically the day into different chunks and go about your different timing plans that you want to have. Or, how this traffic patterns during the day, changes that, is demands, different, bandwidth to have, for different timing plans. This tool is geared toward teamwork. So, if you have, multiple licenses within one agency, it allows multiple people to work on the same, basically corridors, on the same, arterials with signals. And then one beauty of this tool that right now we are working on it and it's going to be rolled out pretty quickly is going to be exports of analysis into HCS and core sim. So as I said, CodeGreen is more of an operational level analysis. If you want to basically do scenario assessment, what if you add a lane? What if you make changes to your geometry? What if, demand is going to be different in future? For those, we can export analysis into HCS and or TSYS core sim. So we talked a lot about HCS. I want to borrow one more minute to talk about what is HCS, just to make sure that everybody is on board. So HCS basically is a planning level traffic analysis tool. So it does a macroscopic analysis of almost any surface street. It replicates methods in the HCM. It gets used a lot for compliance purposes. LOS provided by HCS is the HCM LOS. I know that almost every software report their own LOS. Very uniquely, what HCS reports is HCM level of service, exactly the same as what the book says. It can do signal optimization, but again, in the context of planning level analysis, scenario assessment, it can do that. It's mainly used for traffic analysis, TIAs, traffic impact assessments, and level of service analysis. So a few things I want to sort of, share at the beginning before we go and take a look into the software itself, CodeGreen itself, is that why you should use McTrans CodeGreen. There are several reasons. I guess first of all, this software won a project from ITS Arizona in 2022. What McTrans does in general is hovers around credibility. That's what, for HCS we do, that's what for HSS we do. We have tried to stick to the same principles here with CodeGreen. That's why the optimization algorithm basically that works is based on well-established methods and algorithms. It is based on data and analytics that comes with it. And there are some uses of AI in the form of meta-heuristic and heuristic algorithms in a responsible way. Nowadays, when you talk about AI, everybody thinks that, we send the stuff to ChatGPT, comes back. No, that's not the case, but in a responsible way, as I said, sticking to our principles at McTrans, this is how we go about signal timing optimization to make sure that, we are offering the same credibility that we are offering with all other software with this one as well. And of course, CodeGreen has the ability to connect to infrastructure and, basically, you guys be able to push signal timing optimizations into the field comeback. There are some steps in order to achieve to that. It's not just maybe the way that we are going to present it today, but that has that capability that I want to make sure that everybody is aware of. With that said, I want to turn the floor over to James. I'm going to stop sharing my screen, and James is going to walk you through McTrans CodeGREEN, and we see how this software looks like, how we can use it, and what are the capabilities and features of it. James, floor is yours.
Great. Thanks, Bob. So just want to make sure the screen is showing for everyone. So I think we're sharing here. This is our CodeGREEN cloud-based software. We're gonna show you just a short demonstration of the basic ins and outs of the software. So we'll start with creating arterials and defining our intersections, and then of course the important importing of data. Specifically our turning movement count data. And then we'll show you how easily we can create timing plans and then how easily that turning movement count data can be visualized to help us make actionable decisions. So upon logging in, you're presented with our dashboard here. This is our interface. This is basically divided into two components. We have our timing plan section and our turning movement count data section. And it's just a separation between our visualizations and then our timing plans. Over here on the left side is our corridor or arterial explorer. And you can see we already have one defined here. This left side menu is collapsible, as well as some of the other panels can be expanded for different exporting and visualizations, and everything you need can be done within this one panel for timing plan optimization. So we'll go ahead and start with creating a new arterial. So we have this new arterial button down here in the bottom, and we'll just click on that. We'll give ourselves a name for our particular arterial. In this case, we'll just do a real quick one on 95th Street. We'll go ahead and then locate our intersections for the arterial, and that can be done with a little helpful search tool here. So we'll type in a location, and once it's found the location, we'll go ahead and select it. And that'll take us into an intersection level view, satellite view. We'll go ahead and click on new intersection here at the top and drop in our circular pin, give it a name again, and this will start our first intersection. I'll go ahead and then quickly add a couple more intersections. We have more of a complete corridor here. This is 95th and Santa Fe, and then we'll add one more. So once we have our intersections added, we'll need to then define some more information on the corridor, specifically for our time space diagram and our bandwidth optimizations. So over in the arterial setup tab, you'll see there's some information we have. Our forward direction is listed, and this is just kind of our primary designation of the direction from the given list of intersections. So we'll just indicate the distances here that we have on the roadway. So approximately 3,700 feet, and then approximately 1,600 feet here. We'll indicate the speeds between the intersections as well for, of course, time space diagram and bandwidth optimizations. There's a couple other parameters here that you're able to provide, and that's sort of minimum and maximum. So if you have certain laws or governing criteria that you want to maintain, you can, of course, put that in here. In this case, we'll allow the system to kind of search within these bounds and give us an optimal cycle length. So this is adding the intersections in the core to our arterial. Lastly, we'll need to come in and provide some geometric information. So we'll need to have an understanding of how many lanes there are and what the movements are within those lanes for each of the approaches. So in this case, if we have 4 approaches, we'll go ahead and configure that correctly. We'll also need to indicate some level of left turn position, whether or not at this particular intersection we're forced to lead the left turn, or whether or not this intersection allows us to lead or lag. Selecting the second option gives the optimization routine an ability to select the most optimal position for the left turn, both for bandwidth optimizations or even delay. So the other items here then you'll provide are the phase times. So you'll, of course, want to adhere to controller timings for min clearance and all red intervals. And that way the system will ensure that the phase splits provided fall within that criteria. Once that is all set, then you're basically done with everything you need for the initial setup of the corridor and intersections. After that, all you need to do is import turning movement count data, and at the click of a button, you can create timing plans. And you can do that as much as necessary or as needed for however many plans that you want to have created. We've already got a corridor over here, so we'll go ahead and click on that corridor and see if we can access the timing plan creation. We'll show you how easily that can be done. So over here on this corridor we have created, we'll click on New Timing Plan. We'll go ahead and give our plan a new name. We'll say we're going to make another AM peak plan, just a new one. So this will be our new AM peak plan. The next thing we need to do is import some turning movement count data. So we'll go over to our TMC import section. We'll click the import button up here at the top. This is where you can click here, or you can drag files to upload. So we'll click in that region. We already have a few files that we've collected data for each of the intersections. So we'll go ahead and highlight all those files, and then we'll just click on the import button. This gives us a little warning that if any of the data kind of overlaps some existing imported data, there's a potential that it'll be overwritten. So we've got that data imported. The next thing we need to do now is select the turning movement count data we want to use for this particular plan. So up here, we'll select the import from database option, since the data is in our database. The series of dots at the top are a reflection of the 6 intersections that we have. We'll go ahead and just pick one of the intersections, and we'll go ahead and pick the date. Now, the turning movement count data was imported on the the timestamp in the file was for the 13th, so we'll select August 13th. We're going to go ahead and select the same time range just to make it quick for all the intersections, but you can pick individual unique time ranges for any of the intersections individually. We'll click on this Apply Time Range to All button here. What that's going to allow us to do then is for the first intersection, we'll highlight the AM peak time period from 6 to 9, and we'll click Import. And what we can then see is that all of the other intersections along the top are also indicating they've imported their data as well. So if we change to another intersection, we can see that the imported highlighted data is for this time range, and so on and so forth. So that's all we need to do. We'll go ahead and click Save. Now we have our turning movement count data in our TMC selection. We can see that here. This is the data that we're going to use for this analysis. We'll just at a click of a button, click Calculate. The system runs off, determines what the optimal splits and cycle and offset need to be for each of the intersection, what the optimal sequences should be, and this is a resulting timing plan that comes from that. So you can see we have a suggested cycle length of 120 seconds. There's also some information within each of these that shows us our sequence and our phase splits. You can, of course, tailor any of these things to your desire. If you prefer that certain movements occur in certain ways, you can rearrange these things. You can swap phases or just drag and move them over, and they'll automatically dynamically adjust. You can also just adjust some of the split durations as well. And really, there's a lot of flexibility here in what you can do. There's also icons. These lock icons allow you to lock down certain parameters. So if you do a series of timings and then you come back 6 months later, you have new data for a given intersection, you can go through and lock down all the parameters on all of the other intersections, and then maybe just release some of the parameters on the single intersection with updated data. And then you can recompute the entire solution again. It'll recompute all the parameters for the one intersection, leaving the other ones in a lock state and using their existing sequences and offsets and phase splits. Over in the time-space diagram, there are additional lock icons that can be used to lock the offset point. So for instance, if I wanted this offset point to be somewhere down here for some particular reason, I can set it to 7. You can see that within our time-space diagram that our offset is at 7. This offset in this configuration is referenced to the start of green for the leading coordinated phase. So once we have set that and locked it, anytime we recalculate, it'll go, and anything that's not locked will kind of be recomputed. So you can see the entire solution has now been updated according to that offset for this one intersection. This is helpful if you're doing cross-corridor coordination, for instance, and you may need to position a particular intersection at a particular offset to ensure that coordination along the other arterial that's crossing is maintained as well. And so this is kind of a helpful way to do that. You can see if we unlock and then recalculate, it just kind of gives us the standard solution that it came up with. So those are some of the things that we can do within the timing plan optimization. Once we have the final plan in place, we can do various things. We can export the time-space diagram. So clicking on this button here at the top gives us an ability to basically does a PDF rendering of what you see here. So you can, if you're producing artifacts for certain projects, this could be an artifact that gets produced. This will, again, just take a rendering of what you see here. You can save that away, and then you can go view this at a later date. The other things that we can set in our intersection configuration is the offset reference point. So we can see that this reference point, like I indicated, is a leading green reference point for the offset. But if your controllers, most controllers prefer maybe a lag yellow, which is sort of end of green, or a lead yellow, which is the end of green for the leading phase, it can produce and show you what the corresponding offset would be for that. That really applies more or less to the output timing plan itself. So if we come over to this particular timing plan we've constructed, we can export it and we can save that. and then we can go and pull that up and take a look at that particular plan that we created. And this is what the corresponding plan would look like. So this is showing us our offset for that intersection at, the end of green for the leading coordinated phase. In this case, we've indicated that the leading coordinated phase is 6. The other intersections are still configured with their start of green. So you have your timing plan in this view as well as phase split type view as well, more of a common phase duration. And that's very simply everything that's required to construct an optimized timing plan. Now, within the turning movement count data section, there's a lot of different charts that are available. Each of your corridors here is listed on the left in the Arterial Explorer. And there's various charts here. There's directional split charts that allow you to see different behaviors throughout the day. In this particular case, we can see that the corridor is very heavily northbound in the morning, and then about in the middle of the day, it switches to southbound volume. And this is just due to the fact that this particular location is a lot of commuters are moving or going to the north into the city, and then when they come back home in the evenings and throughout the day, it's just more heavily southbound. There's other various charts here that can be used. There's critical volume charts, some peak hour factors that are shown per movement. There's heat maps that you can visualize weekly turning movement count data with different thresholds here that can be applied to sort of visualize the high levels of volume in different ways. So those thresholds can be constructed to suit the volume levels and showing you at a glance where the peak volumes are at this particular intersection throughout the day and throughout the week. There's daily traffic charts as well that you can use to plot a series of days or time ranges and be able to sort of see throughout what sort of the trends are. There's moving average charts, which again can help you with that sort of trend analysis. And then other charts including departure rate. There's also some various comparison charts that you can select, which will allow you to overlay different days and allow you to compare some of the results from that. So this is a comparison chart of critical volume and one of cycle length. To create any of these charts or tabs, you just merely click on the plus button and you'll be presented with a new tab. You can rename, duplicate, or delete any given tab that you have created. To add a chart to a given tab, you'll just select the intersection here on the left. You'll be presented then with a series of charts that are available. So we're just going to very simply grab one of these here. Let's try the TMC per movement chart. So initially, there's not going to be any data displayed because by default, it's selecting data from today, which we don't have. So we'll go ahead and click the edit pencil. That'll take us into a calendar view where we can see where different data is available. So we can see the turning movement count data we imported is for the 13th. So we'll go ahead and click on that date. And within a few moments, we'll see some data then that corresponds to the turning movement count data for the eastbound. So some of these charts are formatted differently where they'll have different selectable data components in the lower right. So in this case, it's by approach. We can also see a view of just the totals. And then within each of those, we'll highlight the peak value, the peak hourly time period for some of the movements as well. There's lots of different charts to pick from. You can customize this to your needs. Every user, their series of data visualizations is unique to them. So every user will have their own unique set of charts that they've created. They can customize it to suit their needs. But all of the users within your agency will all share the same turning movement count data, the same intersections and arterial configurations, the same view into the timing plans, etc. And then there's different coordination schemes that occur behind the scenes to ensure that only one user is making changes to an arterial at a time. So there's just some safety measures that are in place to ensure that two users aren't trying to edit the same arterial and then their changes sort of override each other. Well, that's a very high-level demonstration of the software. I think I'll turn it over now for the remainder of the webinar and questions and see what other feedback we have.
Thank you, James. So let me share my screen again. And actually, what we want to ask next from our participants in this webinar is what features would you like to see in the upcoming release of McTrans CodeGREEN? So if there is anything that came to your mind and you think either we may have it, by the way, it doesn't mean that we don't have it, but it comes to your mind and immediately you think that, hey, that's what I want also to see there. We would love to basically hear those and record those in here. So maybe give it a minute, see what you think about it. Also, we have received a number of questions in the Q&A section. Uh, so we have another panelist that just joined us, a few minutes after we started this session, who is Reggie Chandra, founder and CEO of Rhythm Engineering. He has responded to a couple questions. I believe a couple more are left. So we'll give it a minute for you to think about this question, which Fabio just launched our poll system so we can capture basically, what you guys are thinking of. So let's do this and then we'll dive into Q&A section. If there is anything at the end you guys wish to see, you want us to maybe expand more or maybe dive deeper into CodeGREEN, we will be more than happy to do so. So I see here in my dashboard that a couple people have already posted their points, their answers to this question. All right, I see more is coming, but maybe for now, I'm gonna leave this poll be running in the background so that if you guys think about anything that you want to add, you do. This is a great time for us to take a look into questions that you guys have posted. Uh, Fabio, do you mind if you go over questions and maybe for the ones that we have not answered, first let's ask James and Reggie, and then for the ones that Reggie already has responded, we can maybe repeat them so that make sure that everybody has heard them.
Okay, great. So thanks everyone. We still got the poll running, so you can still type your inputs while Q&A is running. But I will start reading through some of the questions. Some of them were answered in written already. So let me start with the first one here. So what MOEs are the optimized timings based on, and where can you inspect those?
James, do you want to?
Reggie, I think you were muted if you were trying to say some things.
I said, James, what measures effectiveness? You can take that question.
Oh yeah. So we're looking at bandwidth optimizations. There isn't a visual output to show these things, but the measures we're looking to optimize around are bandwidth optimizations. We're looking at critical volume and how that plays into cycle length optimizations, and then split optimizations based on, of course, volume distributions. It'd be pretty easy to add some different charts as well that would help you kind of visualize those MOEs. One of those things I believe is the saturation or sort of volume over capacity component that we're looking to add as well.
All right, let's move to another question. Is there a specific format or template that the TMC Excel file needs to be in to be imported correctly?
Yeah, there is a format in that'll be provided. It's simple Excel style where there's a couple rows of information. One is just a header for uh, the given movements, and then one is a date and time column. Aside from that, the format's fairly simple and we can provide that, but at the same time, we're going to try to see if we can't build it, make some changes to allow things to really be much easier to format. So all you really need is a date and time column. And I think what we can do to make it so that you won't have to have a template is just make it very simply that the first row is your headers. And as long as you provide all the required headers, date, time, and then the movements themselves should be fairly straightforward for us to figure out the rest of what you've provided. So that's our plan. But for the current time, there is sort of a formatted template that we can definitely share with everyone.
Thank you, James. Next question, maybe that will be for you, Bob. Can you get a copy of the slides?
Sure. As I said at the beginning, we were planning to post this on YouTube, which is going to basically have all the slides. But if anybody has a specific interest to have the slides, I'm more than happy to share with them. So I guess in the next slide here, I have our emails basically listed. If you guys can email me your request, and then I'll be more than happy to send it to you.
Okay, thank you. There was a question that was already responded in writing, but maybe we want to explore a little bit further. So, James, can you elaborate how can teams collaborate when using this tool simultaneously?
Yeah, very simply, you can have as many users logged in to the cloud-based software as you have licenses for. Every group will be part of, and the users within that group will be part of the what we refer to as an agency. So if your agency has 10 users, then all of them can be logged in, of course, and you'll be shown your um, uh, uh, all the arterials that have been created within your agency. So if one user wants to create an arterial and define all of the intersections and set all the phase times and lane configurations and things of that nature, um, they can do that. And then all of the other users will have access to that as well. So all of the other users within the agency will be able to also make adjustments as needed or, update things as necessary. But to ensure that there's no conflict where one user is sort of making changes to an arterial, and another user may also want to do some changes, in order to ensure that those changes don't override each other, when you log in to the system and you expand on one of those arterials, you basically will end up locking that arterial, we call it. So you'll see a lock icon on the arterial, and what that will do is that'll prevent others from also being able to open that arterial and make any changes on it. You'll be given a notification as to who has the arterial locked. And then what'll happen is if they log out or if they click away or to another part of the software, it'll automatically unlock. But if they have outstanding changes, the software will ensure that you want to navigate away before you save your changes. So you'll always be checked to make sure that you're not moving away without saving your changes. And then once you have your changes saved, then the next time the next person comes along or yourself comes along and opens that arterial, you'll see and it will reflect the latest changes that have been saved. And so the teams can collaborate safely without any worries that there's going to be changes that they overwrite from each other. There's also different levels of users. So there's view-only users, and there's regular users. Regular users will have full access to make changes and edit things, whereas view users will only be able to sort of see what's been created in terms of the arterials and intersections. They'll be able to browse them. They'll still be able to construct their own charts and visualizations and things, but they'll just be restricted from making changes. So.
Okay, thanks, James. And I see, seems like a follow-up question. Is there a limit to simultaneous users on CodeGREEN?
Theoretically, no. There's you could have any number of users logged in to the system. So the only limit would be your licensing agreement and what that structure looks like.
Okay, all right. Next question. Do we have to install anything? So I suppose the question is about whether it is a desktop application or is it all on the web?
It is all currently on the web, and there are various ways that it can be self-hosted, but this particular instance is cloud, what we call our cloud-hosted version. So all of your users and everyone within your agency would access it through a standard web browser. As long as you have an internet connection, you'd be able to pull up the site and log into it.
Okay, thank you. So right now, I don't see any other pending questions. So maybe we can give another minute to our audience, see if any other questions at the end.
Maybe, Fabio, while we are waiting for additional questions to come, I was looking into feedback that we have received on the poll question and the features that, some of our audience, they wish to see. One of them is supporting probe data, for example, speed, travel time, trajectory. I don't know if Reggie, James, you guys have any inputs to share regarding, supporting probe data, how that can be done, or is it basically doing that as of now or not?
Yeah, there's the probe, sort of the outputs of the probe data itself aren't necessarily, there's no way to sort of incorporate that. You couldn't use the probe data to sort of adjust the speed configuration that you have, which is going to, sort of directly reflect how folks travel on the roadway. But aside from that, you would just use your probe data, of course, will help you with um, sort of a measure of effectiveness with the result of your optimized plans. If you're referring to probe data in terms of counts, we typically are just looking at, turning movement count format, so we don't have any counts in terms of probe data that we make use of.
Okay. So I see another comment about uh, one of our audiences wish to see capability of import-export timing charts directly to signal controller, to or from signal controller.
Yeah, the import directly to, since it's cloud hosted, it is there's not any infrastructure that would allow you to have it push directly into your network or into your controllers. There are solutions that are available where, like I alluded to, there are some self-hosted solutions and hardware solutions that can facilitate the sort of those sorts of things that you're looking for. Bob kind of touched on those earlier and indicated that it's sort of a different variant of what we're seeing here. But some of those things are possible. We just have to kind of work with you and your team to figure out what those requirements are.
Yeah, it would be good for those of you who have made comments if this system doesn't let us know like who is who, so these are coming to us as anonymous comments. But if you wish to continue this conversation, we appreciate it if you guys can connect to us so that we can basically work more on this conversation and at the end basically we try to tweak our software in a way that best serves for your purpose.
Okay, and I see there are more questions in the audience too, but they're actually about the same topic. So, is the software capable to communicate with other simulation software, such as Synchro or vSim?
At this time, we're just working on the export to the HCS so we can do core sim analysis. Exporting to Synchro, it could be an option, but it's something that we'd have to discuss and determine whether or not that's basically a path that should be pursued. But my understanding is that it should be doable given the format that the Synchro configurations are in.
Well, thanks, James. And at the moment, I don't see any further questions. Maybe let's see if anyone else still wants to send any further questions.
And of course, we have our contact information on this slide. If anyone, any question comes to your mind, after this webinar, for sure, make sure that, you guys get in touch with us for any question. We don't want end of this webinar to be the end of the period in which you can ask questions.
And I think I caught a typo. James's email would be james.bly.
Oh, all right. Thanks for catching that. Yes. So it's james.blay.
Yeah.
Okay. I still see questions coming in.
Okay.
Have the results been put into a real-world system and the benefits measured?
Yes, there was a study that was done by HDR in city of Maricopa, Arizona, funded by Maricopa Association of Governments, that saw significant, I think about 44% reduction in travel time using the CodeGREEN optimizer. And incidentally, it won the ITS Arizona Best Implementation Project. So yes, it has been validated and it is operating in the field.
Okay. Thanks, Reggie.
All right. I guess I don't see any other questions coming in. And as I said, first of all, I fixed James' email, so james.belay@rhythmtraffic.com. If our audience, you guys have any questions or anything, that creates interest for you to talk to us, you have our email, and we'll look forward to be talking to you. Before we adjourn, any other thing from my panel members that you guys need to share before we adjourn? I guess Reggie, James, any last minute thing?
Nothing for me. Again, I appreciate the opportunity. Thank you all.
I appreciate everybody joining us.
Yeah. Same as I. Thank you very much, everybody, for taking the time coming to this webinar and providing us with your questions, your feedback. We appreciate that. Have a great rest of your day.